Okay, so here is video number 2. Model. So you need the sheet, you need your calculators, and what I want to do is review the intersect key, the maximum key, and how to intersect to find your x-intercepts or your horizontal intercepts. So this problem is about a tennis ball that's just kind of flicked upward. It's not, they didn't whip it up as hard as they could. They just kind of tossed it gently upward. And the height in feet of the tennis ball is given in this chart below. This is a question I pulled off of my math lab. So I want you to make a scattered plot. So we're going to use our calculator, and the key word is stats when you're making a scatter plot. So to enter data into our calculator, we're going to hit that stat key and hit enter. And then the first column is going to go into L1. I'm just entering in the data and hitting enter. And then the second column, the heights, are going to go in L2. All right. So first thing I want to do is remind you how to make a scatter plot. So I always quit out of this mode. You see quit there? So I just quit out of it. So I'm on a clean sheet of paper. And to make a scattered plot, you're going to go up to stat plot. Mine's in blue, so I'm going to hit the blue key first. And I'm going to turn a plot on. Now, I always hit zoom and then number 9. It's zoom stat, and that's going to make a window so that all of the points will show up on your screen, okay? So that is like the first way in which I let the calculator help me out to make a window. So now let's go ahead and calculate the regression curve. So I'm going to show you how to actually have it go into y equals. So we're going to calculate, so word of the day is stat, and we're going to calculate a regression. Now we've done linear regression in here, and now we're going to do quadratic regression. So it's option number 5. And then, of course, L1 and L2. And then if you want to be able to have the calculator just pop the equation into your y equals, we just need to tell the calculator, hey, I want you to put this into y1. So to find y1, that's your vars key, your variable key. So when we hit vars, we want the y variables. So scroll over to the right and hit enter. And now we're going to tell the calculator, hey, can you pop that into y1 for me? And then calculate. So I'm going to write this down. I'm just going to round it to 3 decimals. I'm going to use t squared because it's in time. And then if you hit y equals, you'll notice it's in there already. It's kind of nice. And when we hit graph, there's my graph. Okay, so now let's use this model to answer some questions. Now, a lot of people miss this question on their OWOW. It says using your model, so that's right here, find the F-intercept or the Y-intercept. That's the same thing. So this is when t equals 0. So when t equals 0, we just have that c value left. You can see it's pretty close to the actual value, but remember, it's just a model, right? It doesn't go through exactly every point, and you can see that this is just a teeny weeny bit above the y-intercept. So this is what the model approximates the height to be. It's very close. And what does the F-intercept mean in terms of the problem? So according to the model, at time t equals 0, or right before the ball was released, it was 1.979 feet above the ground. Okay, so moving on. So now we're going to use this model to answer some other questions. So it says, tear that off, using your calculator, find the t-intercepts of your model. So the t-intercept are the x-intercepts. Here's my t, here's my f or my y. So the t-intercepts are going to be when the output is 0. So I'm going to set the y equal to 0. Okay, now this is already into y1. So I'm going to put this into y2 and then see where they cross. Now we're going to have to do a window adjustment. But let's pop y2 in here, is 0. Now you're not going to see anything down here because our window for y, look at, let's hit my window. Look, the window doesn't have 0 in it for y. So we're going to have to change our window a little bit. So if I want to catch 0 for y, maybe we should make that -1 for the min. So now 0 is going to be stuck in between those two. All right, so now we can see the intercepts, or we can see this axes, but do you see the intercepts are beyond my finger and my pen? They're maybe over in here. So I need to make my x smaller and my x bigger for my window. So when I go to window, I need to make that a little bit smaller. So, I don't know, let's try -1. And I need to make that a little bigger. Let's try 1. Just trial and error. Oh, this should be nice. Okay, so there's the path of my ball. Now, we're going to have some model breakdown, but my math lab would like to know what these intercepts are. So we can't see that line being drawn, but y equals 0 was drawn as my second graph. So when we go up to calc, if you're trying to find something on your graph, if in doubt, go to calc, option 5, and we hit 1, 2, 3, enters. There's one of my intersections. So my one intersect is -0.215, 0. And then to find the other one, remember you have to tell the calculator, hey, when I go to number 5, intersection, and I work my way over, I want you to find the one on the right instead of the one on the left. And then when we hit 3 enters, there's my other t-intercept. So at point, let's see, 669, but if we round that, I'm going to say 0.607, 0 is my other intercept. So when they say what do they mean in terms of the problem, well, the input is time. We can't have a negative time when we talk about throwing a ball up in the air. So the first point is model breakdown. You can't have a negative time value at -0.215 seconds. That makes no sense for this problem. But this one definitely makes some sense. So at 0.670 seconds after the ball was released, the height is 0. Or another way to say that is that the ball hit the ground. All right, so my math lab actually talks about model breakdown. So it says, well, where does model breakdown occur? Well, you can't have a negative time. Like this is when the ball was released above the ground. So anything before this value for x or for time, any time less than 0, that has model breakdown. Like none of these values make sense. And then do you see after the ball hits the ground, right? Chances are it's going to bounce back up, but for this problem, this is where it hits the ground. If you keep on going, it like breaks through the sidewalk and is below ground level. Like this doesn't make any sense in here. So after it hits the ground, you've got model breakdown, right? It's not going to go anywhere according to that graph. So when t is greater than the 0.670, that doesn't make any sense on your graph. So the only parts that make sense are from here, t equals 0, to when it hits the ground, t is 0.67. Anything beyond that, bigger than 0.67 or less than 0, the graph doesn't make any sense. There's model breakdown. Okay, and then the last thing is they want to know when the maximum height occurs, and that's the vertex. But we can find this on our calculator. So if in doubt, go to calc, and the maximum key is number 4. Now this is where you have to bound it. So we need to get our cursor to the left of the vertex. Right now it's definitely to the right of the vertex. So I'm going to scroll over. All right, now it's to the left. Hit enter. Now it says get it to the right. You see it says right bound it. So now I'm working my way to the right. And then hit enter at guess. And there's the vertex. So this is the point it gives us, 227, 2.687. Okay, and the input is time, and the output is height. So the ball reaches a maximum height of 2.687 feet at 0.227 seconds. All right, so I opened up just 2 of my math lab questions. They have parts to it like this. This was a my math lab question. So give those a try using your calculator. Now the other thing I wanted to go over, and so you could just flip this page because you're going to hand in these notes and do these problems, take notes on these problems on the back of this. What I wanted to do is I wanted to go over the completing the square problem. So this was the problem on the test, and I want to go over this one, and then I want you to do this one on your own and hand it in as part of your packet. So a lot of people had trouble with this on the exam, so that's why I want to go over this. So to do completing the square, the first thing you have to do is get the x values on one side and your constant on the other. So I'm going to subtract 17 from both sides. Now over here, we're going to identify what b is, we're going to identify what half of b is, and we're going to identify what half of b squared is. These are 3 pieces that we need to be able to use. So b is -6. If I take half of b, that's -3. And then if I square -3, that gives me 9. So this is the value you add to both sides of the equation. Okay, so x squared minus 6x plus 9 is negative 17 plus 9. Now, this left-hand side is now rigged. It's going to be something squared. The first term will be x, and then this value is the value that goes into the second seat. So it's going to be minus 3. That's why these three pieces were important to determine. The b is what you need to identify. Half of b we're going to use, and then half of b squared we're going to use. And now we're going to use the square root property. So to undo a square, we take the square root of both sides, and don't forget about the plus and minus. So these cancel, and the x minus 3 comes down, and then we have plus or minus root negative 8. Now we'll add 3 to both sides, and then we're going to simplify this. So if I add 3 to both sides, this is my answer, but we need to simplify root negative 8. Okay, so I'm hoping you'll agree that negative 8 is negative 2 times 2 times 2. So we can pull the negative out and call it I. And then if we see 2 of something, we can pull 1 out. So a simplified version of this is going to be 2 times I times root 2. And that was the answer I was looking for on the exam. So now that you have that process down, what I want you to do is I want you to rewatch the video if you need to, and then solve this by completing the square and simplify. So solve and simplify this. Solve and simplify by using completing the square. Okay? All right. So this packet is due on Monday. If you have any questions, feel free to reach out.